Real-world computer programming for kids of all ages. Step 47, creating the related tables. Welcome back, everyone. Some of you may have noticed that there were a couple of columns in our movies_main table that I hinted should change, but did not actually change them at the time in the last step, number 46. These are the director and screenwriter columns. As many directors direct more than one flick, and many screenwriters have written screenplays for more than one movie, we should store the names in separate tables so as to adhere to the dry principle. Thus, rather than have director and screenwriter columns with Varchar 50 data types, these should be director_ID and screenwriter_ID columns with int data types. I made those changes to the table, and you can see the result below. And the screenshot shows those changes. Note, I won't go into great detail about how I changed those two columns' names and data types, because this, how to refactor a table structure in DBWB, was covered in detail in an earlier step. In a nutshell, though, make the change directly in the Columns tab to the column or columns you want to alter. Change the column name value, change the column type value. Select the Create/Alter icon, and wallaby! No muss, no fuss, the table structure has been changed. Unless, of course, you already have data of the old data type in the table. That could cause problems, as the existing data probably won't match the new type of data in the altered column. But since we don't have that problem, we haven't populated the database with any data yet, we won't worry about that. Now, in connection with that refactoring we did by altering those two columns, we will create separate tables, not only for directors and screenwriters, but also for actors, and two for genres also. This is what we will create. And it shows those first three tables and their structure: actors, directors, screenwriters. You can see that the actors, directors, and screenwriters tables are all virtually identical. All but the name of their ID column are identical, in fact. If we wanted to, we could even make them all one table, name people or persons perhaps, and add another column that would identify which type of person was appearing in the table in any given record, that is, an actor, a director, or a screenwriter. True, this would normalize the table structure even more, but sometimes the perfect is the enemy of the good, and this is one of those times. In other words, we should leave well enough alone this time. A reason why we don't want to further normalize the database structure in that way is if we did that, we would have to create yet another table called a lookup table that would hold only 3 records with 2 columns: person type, ID, and a person type. These would be the only 3 records in that lookup table, and it shows what it would be: 1 actor, 2 director, 3 screenwriter, those 3 records. The additional column we would have to add to the person table, which would replace the 3 more specific tables for actors, directors, and screenwriters, would be the FK foreign key person type _ID, which would hold a value of either 1, 2, or 3. An elegant design? Perhaps. Tricky? Yes. But so not worth the degree of extra work and potential confusion it would bring about. Also, the fact that some people wear 2 or more of these hats, actor, director, screenwriter, during their career could confuse things, such as Ron Howard could appear in that person table both as an actor with 1 person ID and as a director with another person ID. So we'll leave the table structure as it is for sanity's sake, to keep it all from getting too complicated. Note, you will find that when you are designing software and in the zone, you will come up with some designs which to you at the time seem elegant and logical. Elegant is another word often used by programmer types with a meaning that varies, perhaps significantly, from the way a fashion designer would use that word to describe a classy model snazzily attired. But when somebody else tries to make heads or tails of your code, they are flummoxed and bamboozled. Even you, coming back to the code later in a cooler frame of mind, may wonder, what was I thinking? Another good acronym to remember in situations like this is KISS, K-I-S-S, which stands for Keep It Simple, Smarty Pants. Here's how these tables, actors, directors, screenwriters, will work. When an actor's name is encountered for the first time, it is appended, added at the end, to the actors table and assigned the next actor ID value as its unique primary key. For example, if there are already 187 actors in the table, and Richard Farnsworth gets read in for the first time, the actors table record for Mr. Farnsworth would be actor ID 188, first name Richard, middle name William, last name Farnsworth, suffix blank. Note, in most cases, we won't really need a middle name to be provided. In this case, we didn't really, because there is not another actor named Richard Farnsworth to cause confusion. The same is true of the suffix column. It's left blank above and normally will be. But think of these scenarios. What if there was another actor named Richard Farnsworth? Then we would have to use the middle name to tell them apart. Richard William Farnsworth and Richard Lionheart Farnsworth or whatever. Then again, what if there was a father and son pair, both named Richard William Farnsworth? That's where the suffix column is of value, and so we would have Richard William Farnsworth Sr. and Richard William Farnsworth Jr., or Richard William Farnsworth II, to tell them apart. So how does this help us? We want to know which movies an actor performed in, and which actors are in a given movie. In other words, we will want to query the database asking, in effect, show me all the movies in which Robert De Niro appeared. Similarly, we will want to query the database regarding all the actors which were in a particular movie, such as It's a Mad, 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 Mad World. That's 4 mads. And that's the actual title. How can we do this? How will it even be possible for the database to give us this information? The answer? We need to connect this data, the movies, to the actors. We need, in database terminology, a relation between the movies and the actors. But the main table, movies_main, does not even have a single actor ID column anymore, let alone the 3 it started off with in our proposed table structure design. How are we going to make this connection or relation? I will answer a question, admittedly my own, but possibly it was in your mind too, with a question. Here's my counter question, my rhetorical question. Have you ever heard of a many-to-many table? That's when a table contains many identical values in one column and many identical values in another column. But taken as a pair, they are unique. And it shows a picture of representing a many-to-many situation. See if you can see how this many-to-many table will help us make this connection or form this relationship between movies and actors. And it shows an actors_movies table with an actor ID of integer data type and a movie ID of integer data type. Do you see it? Let's visualize the data with a few sample records. Say that in the actors table, the actor assigned the actor ID value of 1 is John Wayne. And say that in the movies_main table, the movie Stagecoach is assigned the movie ID of 894. True Grit is assigned the movie ID of 2768, and The Shootist is assigned the movie ID of 3261. Those 3 records would appear this way in the many-to-many actors_movies table. And it shows those 3 records with all having an actor ID of 1, but the movie IDs being 3 different things. Although to a human it looks like pure confusion, just random numbers, it is actually in effect storing the following, but in a more efficient way, and it shows actor as John Wayne in all 3 cases, and movie title as Stagecoach, True Grit, and The Shootist. This is so because the record or row in the actors table, which has an actor ID value of 1, also contains John in the first name column and Wayne in the last name column. The situation is similar with the movies underscore main table. The record with a movie ID value of 3261 has the shootist as its movie title value. By using a many-to-many table in this way, an actor, his actor ID value that is, can be stored as many times as how many movies he or she has appeared in. Dozens and dozens for John Wayne. And a movie, its movie ID value, can be stored as many times in the actors underscore movies table as there are actors in that movie. The same actor ID could theoretically appear dozens of times, and the same goes for movie ID. But to have the same pair of IDs appear more than once in the table would be redundant and should be guarded against. Another table we need is the genres table. Yet we don't even have a genres column in the main movies underscore main table anymore. So how is that going to work? We have to do it this way without having a genre column in the movies underscore main table, because this is another case where there could be multiple genres that apply to any given movie, just as there could be beaucoup actors in any given movie, and usually are. Note, the word beaucoup, pronounced that way, beaucoup, is French for a lot. To keep track of the genres into which a movie may fit, we need to create two tables, a genres lookup table and a movies underscore genres many-to-many table. And then it shows both of those tables, their structure. Genres, the lookup table has genre ID of int and genre description of aircare 30. Movies underscore genres, the many-to-many table, has movie ID, int, and genre ID, int. The genres lookup table would have records such as these, and it shows several, 24 actually, from genre ID 1 with a genre description of action to genre ID 24 with a genre description of Western. And this isn't even all of the genres. This is a subset of them. The word subset is mathematician and programmer speak for some of. Which genres do you like best of those listed above? The movies underscore genres table is another many-to-many table similar to the actors underscore movies table, and so a few of its records could be the following. And it shows an example of just 3 records, all with different movie IDs, but the same genre ID, namely 24. Using the data in the 3 records above in the many-to-many movies underscore genre table and by referring to the movies underscore main table and the genres table, you could deduce that all 3 movies listed above are Westerns because their genre ID value is 24, which, according to the genres lookup table, is that type of movie. And you could also figure out that the titles of the movies are Stagecoach, True Grit, and The Shootist, according to the movies underscore main table. But what if a movie can be categorized as exhibiting the characteristics of multiple genres? That's the whole purpose of breaking this out into a lookup table and a many-to-many table, actually, to handle such scenarios. So you might see a few records like this in the movies underscore genres table, and it shows 4 records with the same movie ID of 3261, but all, of course, with different genre IDs, 1, 9, 15, and 24. By looking up the genre ID values in the genres table, you would see that this movie, again, The Shootist, possibly John Wayne's best, and his last, by the way, flick, is a genre bender. It is considered action, there's a gunfight, drama, romance, John Wayne and O.P. Taylor's mother fall in love with each other, as well as being, which is to be expected considering who the main star is, as well as the title of the movie, a Western. Again, though, how would you know that the movie ID 3261 means The Shootist, and that the genre ID 9 means drama? To look these values up manually in those other tables is tedious at best. We will find out later how to query tables like this to instantaneously retrieve the human-readable values you want. Before we get to that part of it, though, we have to populate the tables with some actual data. That is the cudgel we will take up in the next step. So, until then.